All right, I wanted to do a little bit more review. We've got a separable differential equation, an integration by substitution, and a velocity graph. Okay, so solving the initial value problem. Well, dy dx to y squared multiplied by x. First thing I'm going to do is multiply by dx. Then I'm going to divide by y squared. Okay. Now we get in the habit sometimes of just assuming we're going to need to use natural log, and that's kind of why I did this one. 1 over y squared is the same as y to the negative second. You see, we're not going to need natural log in this one. So the right side is 1/2 x squared plus a constant. And here we raise the power and divide by the new power, we get that, which is the same as negative 1 over y equals 1/2 x squared plus c. Now let me solve for the constant. This is kind of a different way of looking at it. What this says is if I plug 1 into the y equation, I get 1. Well, that means that this is the x and this is the y. Okay. Not that it made a difference in this one because they were both 1, but important to look at. So negative 1 over 1 equals 1/2 multiplied by 1 squared plus c. So negative 1 equals 1/2 plus c. So c is negative 3/2. Okay, so let me take that from right here. What can I come up? So I've got negative 1 over y equals 1/2 x squared minus 3/2. So let me change the sign on everything. Maybe make this plus, negative, positive, like that. And then all I'd really need to do is do the reciprocal. So let me just take this, because it has a common denominator, and write it this way. Negative x squared plus 3 over 2. So instead of 1 over y, I'm going to write just y over 1, which is just y, and then flip the other side as well. That, and this is our differential equation, or our original equation. So every single time we start by separating, and we integrate, and then we use every algebra trick we got to solve for y. Now this example of substitution is a little bit different in that it's going to require a first step. And I wanted to do this one, but I want you to realize I wouldn't ask you to do this one on a test, and the AP exam wouldn't either. I will point out the spot that I get to where I would say this would be a fair test question. But what I mean by all of this introduction is that this, you look and you say, well, I'll make u the sine of 2x. Unfortunately, then the du would be 2 cosine 2x, which I don't have. So we need to use a trig identity. We need to remember that sine of 2x is the same as 2 sine x cosine x, which means I could rewrite this 0 to pi over 4 as 2, let me put that out front, sine x cosine x multiplied by cosine x dx. So replacing the sine of 2x with a double angle identity, which then, coming down here, 0 to pi over 4, I could say is sine multiplied by the cosine squared of x. Now, at this point, I think it's a fair question for a test, or even the AP exam. I wouldn't have expected you to remember that trig identity, but I just thought it'd be kind of interesting to look at here. So I'm going to make u equal to cosine. Okay, should always make it the one being raised to a power. So du is negative sine of x dx. Okay, so I'm going to make it positive, change that. So I already have a 2 out there, so now it's negative 2. And I'm going to be able to take out the sine of x and dx. Remember, we talked about the fact that we're trying to get rid of products and quotients, and I'm replacing the entire product stuff with a du. So that makes this a lot easier. It just becomes u squared du. Well, the antiderivative of u squared is 1/3 u cubed. Now, I didn't change the bounds. Let me do that real quick. Remember, the key is our substitution. So the cosine of 0. So we start with that. The cosine of 0 is 1. So our new bound is 1. Okay. The cosine of pi over 4, right, we plug that in, we get the square root of 2 over 2. So now I've got my integral. Let me just write negative 2/3 u cubed. Evaluate at square root of 2 over 2 and 1. And we could plug that in and solve that, and you can do that with your calculator. But let's just recap here. Again, you would not need to know that trig identity to replace. I just thought it'd be kind of fun to remember that. Right here, when it came out of the box, this I would expect you to be able to do, where you set up that u is cosine, that du gets rid of the product, that we change the bounds. Remember, we're using this. The cosine of 0 is 1, so that becomes our new bound. Take pi over 4. The cosine of pi over 4 is square root of 2 over 2. That becomes our new bound. We do the antiderivative, and then we evaluate at those bounds. And you just plug that in, get an answer, plug that in, and get an answer, and find the difference between the two. Finally, particle moves along a line with the velocity given by the graph to the right. When does the particle change directions? Remember, we change directions when the velocity changes signs. So that occurs at time 6. Okay. Using a graph, we're speeding up when velocity is moving away from 0. And just think about this. Here, of course, negative velocity means you're moving backwards. Positive velocity means you're moving forward. So here you start off with a velocity of 0 and you start moving backwards, but you're gaining speed, right? You end up negative 5 feet per second or whatever. So you are speeding up going backwards, and then you start moving back towards 0. The velocity starts moving back towards 0. That means you're slowing down. So you're speeding up here from 0 to 4 and 6 to 7. Now, when is the acceleration positive? Well, remember, acceleration is the derivative of velocity. It's v prime. So when v prime is positive, that's when v is increasing. That means its derivative is positive. So that occurs from 4 to 7. Okay, now, the last two questions require us to know some areas. So let's start by finding the area here in this triangle. The base is 6, the height is 5. So base times height divided by 2. This area is 15. Okay, now the next thing we have is a little trapezoid here. So we've got a base of 3 and a base of 4 and a height of 3. So, if you want to use a trapezoid, you'd say, all right, half base 1 plus base 2 multiplied by the height. So 7 multiplied by 3 is 21, divided by 2 would be 10 and a half. Okay. So the displacement, well, this represents moving backwards. So you move back 15 units and then forward 10 and a half units. So the displacement would be negative 15 plus 10.5. So negative 4.5. So this particle ended up 4.5 units behind where it started. The total distance traveled, well, now we do the absolute value. for a total of 25.5 total units.